Research is essential to the fields of psychology and neuroscience. Therefore, understanding research design is essential for many of the concepts covered in this course. Let's begin by discussing some of the basic components of research. The first term you should be comfortable with is the word variable. Simply put, a variable is any factor that varies. Some examples are height, weight, caffeine intake, and blood pressure. So, if we were interested in whether caffeine affects blood pressure, we might research this by measuring the variables of daily caffeine intake and blood pressure. The second term that's important is population. In research design, this refers to the entire group that we're interested in knowing more about. So, for example, if we were interested in knowing whether sugar makes kids hyperactive, the group or population we're interested in are all children. If we're interested in Alzheimer's research, then the population would be all people with Alzheimer's disease. So you can see that the population is dependent on the research question. As you can imagine, a population can be very large. For instance, there are a lot of children in the world, making it impossible to test them all. So to make things more manageable, we instead take a sample or a subset of the population of interest. The important thing, however, is to make sure that the sample is representative, meaning that the sample has the same overall makeup as the larger population. You wouldn't want to ask a question about children and then only test female children, because the population of children, of course, is made up of more than just girls. If we want results that are applicable to the population we're interested in, then we need our sample to match that population. Now that we have some of the basics under our belt, we can move on to specific types of research design. So, in general, we can divide research design up into 3 different categories. The first category is what's known as descriptive research. Descriptive research, as the name implies, involves describing phenomena, like how many hours of TV do most people watch per day, or what types of behaviors do children engage in on the playground, or even what types of study habits do university students employ. These are all examples of questions that can be addressed with descriptive research. The next type of research design is what's known as correlational research. Correlational research involves looking at the relationship between variables. For instance, how is X related to Y? When one goes up, does the other also go up? The third type of research design is what's known as an experimental design, and is considered the gold standard in the research world because it involves not just measurement but also manipulation of variables. This type of design allows us to make the strongest conclusions. In an experimental design, what we're asking is whether or not something causes something else. So, for instance, does my new drug cause a decrease in depression symptoms? Now, let's look at each of these designs in a bit more detail. Descriptive designs can be grouped into 3 different types. The first is a case study, where researchers carefully observe or describe behavior in a single individual, or in some cases a small group. This type of design is used when focusing on a unique case like a rare disease or an event that only affects a small number of people. We can't make any broad conclusions based on information collected from a case study, but it does help to increase understanding of unusual behaviors that might be impossible to study otherwise. The second type of descriptive design is naturalistic observation, which is observing an individual in their natural environment. For example, famous primatologist Jane Goodall used this method to first document tool use in chimpanzees. Although this method is most often used to describe animal behavior, it's also been used in studies of human behaviors. Canadian researchers Deborah Pepler and Wendy Craig have used naturalistic observation to provide a rich description of bullying behaviors on school playgrounds. The third type of descriptive design involves interviews and surveys. These can be done in person or via phone or online, and they allow researchers to collect lots of data from a number of individuals, so they can be quite useful. Descriptive research can be an excellent starting point. It allows us to better understand what's happening, but because we're only describing what we're observing, we can't be sure what's actually causing the phenomena to occur. For this reason, descriptive research is typically used to get the lay of the land before moving on to more complex research designs. One of these more complex research designs is what's known as a correlational design. As mentioned earlier, correlational designs seek to understand how variables are related to each other. This relationship is often expressed as a correlation coefficient, which is a number that ranges between +1 and -1. The number itself represents the strength of that relationship. So, for example, a correlation coefficient of 0.8 would be a strong relationship, whereas a correlation coefficient of 0.2 would be much weaker. The positive or negative in front of the number tells us the direction of that relationship. If it's positive, it means that as the value of one variable increases, then the value of another also increases, and vice versa. So they're both moving in the same direction. If the correlation coefficient is a negative number, then as the value of one variable increases, the other actually decreases, and vice versa. This is best illustrated with some examples. This figure shows a type of graph called a scatter plot. Each data point on the graph represents two values for each person. On the x-axis, along the bottom, we have shoe size, and on the y-axis, along the left, we have exam scores. By looking at the figure, we can see that the data points are scattered all over the place, which tells us, not surprisingly, that there's no relationship between shoe size and final exam score. This figure is similar to the last one, but notice that we've replaced shoe size on the x-axis with the number of lectures attended per month. The data points on this figure show a positive relationship so that the values increase together in the same direction. This shows that there's a positive relationship between lecture attendance and final exam grades, with a correlation coefficient close to +1. This last figure shows number of alcoholic beverages consumed per week, plotted with final grades. This shows a clear negative relationship so that the greater the number of alcoholic drinks, the lower the final grade in the course, and this correlation coefficient is relatively close to -1. Correlation design can tell us a lot about the relationship between two variables, and so they're very useful and frequently used in psychology. As previously mentioned, experimental designs are considered to be the gold standard of research, but it's not always an option to design an experiment in practice. For example, imagine you're interested in whether spanking increases good behavior in children. Do you think you could assign a group of parents to spank their child as a form of discipline and then see how those children grow up and behave? It's neither practical nor ethical to carry out this type of study, since some parents may be quite opposed to spanking, so they may refuse to carry out the experimental manipulation. But what you could do is you could look at children who have been raised by parents who use this type of punishment and then see how they behave compared with kids of parents who didn't spank their children. So in this case, you'd be looking at the relationship between spanking and behavior, but you're not requiring parents to do anything that they normally wouldn't. Although correlational designs are a necessity and are frequently used in psychology and neuroscience, they do of course have some limitations. The biggest limitation of correlational design is that they cannot determine causality. One reason for this is the directionality problem, meaning that it's not possible to tell the direction of causation. Imagine you found a strong correlation between parental neglect and antisocial behavior in children. You might conclude that neglect of the parents caused the kids to develop this type of behavior. But because you didn't randomly assign some parents to the neglect group and others to the attentive group, it's also possible that the antisocial behavior of the kids is what's causing the parents to avoid the children. Another reason why we can't determine causality from correlation is the third variable problem. What if actually parental neglect and antisocial behavior are both being caused by a third variable that wasn't measured, such as poverty? It might not be that neglect causes antisocial behavior or that antisocial behavior causes neglect, but rather that poor living conditions are leading to both different behaviors in the parents and the children. So directionality and third variables must be taken into consideration when interpreting correlations between variables. The last type of research design that we'll consider is experimental design. Unlike the other designs, this research method allows you to ask the question, does X cause Y? For example, does sugar cause hyperactivity in children? In an experiment, the researcher manipulates one or more variables and measures the other, while attempting to control for all other factors. By controlling the environment, it ensures that the only difference between the groups is a difference in the variable of interest. So, an experimental research design has two types of variables, the independent variable and the dependent variable. The independent variable is the one that's manipulated and is the proposed cause in our research question. If we go back to the example of whether sugar causes hyperactivity in children, the independent variable would be the sugar. The dependent variable is the one that's measured and is the proposed effect in the research question. So back to our question about whether sugar causes hyperactivity, in this case, the dependent variable would be the activity levels. Although an experiment can have many independent and dependent variables, the most basic experimental design has to have at least one independent variable and one dependent variable. Let's design a simple experiment to ask about the effect of sugar on activity levels in children. In this experiment, we're interested in the effect of sugar, so we're going to try and keep everything else the same. Then we can compare whether the group given sugar is more active than the group that did not receive sugar. If we designed our experiment carefully, we can potentially conclude that a difference in activity is being caused by the sugar. So first, we must recruit a sample of participants. In this case, we're using children. In order to ensure that the groups are comparable before we start our experimental manipulation, it's best to randomly assign our participants to groups. The first group will receive sugar, whereas the other group will receive a sweet substance without sugar. In this case, we'll use artificial sugar. The group that received the active ingredient, sugar, we'll call the experimental group, while the group that didn't receive the active ingredient is known as the control group. At this point in our experimental design, we've just manipulated our independent variable. Remember, our dependent variable measures the possible effect of the independent variable. So in both of these groups, we're going to measure activity level, which will allow us to see whether or not the sugar is causing a change in those activity levels. Now, if we see a difference in the activity level by statistically comparing the two groups, and notice that the activity levels for children in the experimental group, those that receive sugar, are higher than the children in the control group, those who didn't, we can conclude that the sugar caused this effect because we basically controlled for everything else. However, if we don't see a difference between the two groups, then we can conclude that sugar did not contribute to an increase in activity. So that concludes our description of the three basic research designs: descriptive, correlational, and experimental.